Hello and welcome to Chapter 3, Branch Connections. So today we are going to talk about the different types of broadband connections that connect from your network to the ISP, and then that's going to include the remote access connections. So we'll talk about DSL, cable modem, and the different wireless connection that you may have. PPP over Ethernet and how to configure it. We'll talk about how to set up VPN using GRE. And we'll also talk about the Border Gateway Protocol, how to connect different autonomous systems together, what ISPs use to communicate with each other, the routing protocols. Now, this should be pretty quick. Take out some notes. I'm going to ask you to add some notes that you're going to submit for homework. Okay, so let's get started with remote access. Let's talk about the cable modem connection first. So cable is when you have your cable modem for TV. Well, not the cable itself for TV. So now we are going to use the actual cable that's being sent, the coaxial cable that runs into your house. We're going to take some of the frequency that being used for TV, and we're going to send data on those frequencies, and the rest of the bandwidth that is in the cable will be used for your TV or for your video too as well. So your cable, the coaxial cable that used to carry only video, now carries data as well and voice. So that's what we called converged networks. Um, so the cable, coaxial cable, it goes in from your home actually. So by the way, it's only really from your home to the node to the distribute to your whole coaxial cable, and then that's the cable itself. And what carries all the way to the CMTS is the head ends where your cable company is. It's all really fiber. So there's not really much difference between the cable and fiber, except fiber takes the fiber all straight to your home too as well. All right. By the way, the coaxial cable is the cable. The data that is travels inside that cable are wireless. So we use coaxial cable um, to bound wireless signals. So I took some notes that I want you to take. Here is what I want you to know when it comes to cable. All right. So I want you to type these notes right here. The data cable service specification, the DOCSIS, is the international standard for adding high bandwidth data to an existing cable. And the cable termination system, the one that you saw right here, is a component, well, it's right in here, the CMTS, right? That's the exchange of signals between the cable modem and the cable network. All right, and take these notes for DSL and the wireless that we're going to be talking about in a few minutes. So you can hit pause if you want, finish that up, and come back in here. And let's continue. And I'll just continue with the slides. Okay. When it comes to the digital subscriber line, there's less and less of this being used in the Northeast because Verizon has rolled out the FiOS. But DSL uses the plain old telephone system, the POTS, the wires to send you data, even video. So it makes it much easier. You don't have to the wires are already ran into your home. You can get pretty good speed, especially for data. And you know, you don't have you don't even have to. It's all digital. You can get up to 6 megs of connection depending on where you are. You need to be connect. You have to be close enough to a DSLAM, the the DSL multiplexer. Otherwise, you won't be able to get DSL, just like FiOS. You have to be close enough. If you're close within, I think, 6 miles, if I'm not mistaken. Okay, there are two different types of DSLs, there is the synchronous, where you can have upstream and downstream about the same amount of speed. I think it's like a T1 line they can offer you. But most people use ADSL, asynchronous DSL, and that means you will have more bandwidth on the downstream than the upstream. That's because a lot of people, all they do is they click on a link or two, and that's not a lot when they are browsing the internet. And that's the upstream, and you're not really sending a lot of information. But on the downstream, you get a lot more. You're downloading videos, you're downloading images, and things like that. And that's why we use ADSL in most cases. All right. When you get an ADSL, what they do is they send you a micro filters. You put the filters that connects to your phones, so that when the data comes in, they filter out those frequencies for the video and only send in the data for the phone. With your computer, you don't put any filters on, so be very careful. 50% of the problems when DSL was rolling out is people just took the filters and they put them on everything, including the PC. And if you do that, then you're filtering out the data frequencies. And people were complaining that the phone works, but the day you had no connection to the internet. And of course, the guys on the other end told them the very first thing is just remove the filter and you should be okay. All right. Anyway, um, broadband connections also includes wireless technologies that are out there. There are three different types. The municipal Wi-Fi. So this is a mesh of interconnection, a mesh of interconnected access points. These access points, just like hotspots, you may think of your service provider having a lot of hotspots around the city, and they interconnect to each other. So if you are within the city, you'll be connected wirelessly to your network. There is the cellular mobile. I mean that with the 4G LTE that allows you to interconnect either with CDM or TDMA like the GSM phones. No matter where you are, you'll have data, voice, and even video nowadays. And there's the satellite internet, which is a little bit more expensive. You could be in a desert somewhere or in a jungle somewhere and still have connection to the internet no matter where you are. The most widely used are really the top two Wi-Fis. Okay? Those are the different types of broad widely. I mean, I know Fires we did not discuss, but it's something, I guess it's new and it's not really, not everyone has it. And there's a new different types of connections. Gigabit, Ethernet is being rolled out, and there's new technologies that are coming out in the field pretty soon. But for now, that's what you really need to know. Okay. So which broadband do you really need when it comes to cable? Cable has the bandwidth, okay, over DSL. Fiber to the home, the Fios is a little bit more expensive, but the bandwidth is much higher. With DSL it's a little bit less expensive, and but the bandwidth is, you're getting a maximum maybe of 10 megs if you're lucky, I think. But it's offered almost by everybody. Cable is pretty good. The bandwidth is not too bad. You can get close to 100 to 200 megs, but it also has a limit. But 100 to 200 megs is not too bad, for almost everything that you do connection wise. If you really want high quality, then you should go for fiber, but that's going to be a little bit more expensive. When it comes to cellular mobile, the coverage is always an issue depending on where you are. You probably don't want to use that as your home connection. That's going to be very slow. It's mostly, as we probably all know, it's for phones and tablets, connection outside your Wi-Fi when you're outside your home. The Wi-Fi mesh, don't have a mesh network deployed. If it's available, it's a small office, home office in the range. It's not really that big. The hotspots are more appropriate now that Your local cable company may have a lot of hotspots around that you can connect. All you have to do is, if you have your cell phone, you have to log in to your account. If you have your PC, you can log in and give them your MAC address. So once your MAC address is registered with them, every time you open your PC in a hotspot, you'll automatically connect because they'll use the MAC filtering. Just like we use the MAC filtering when we filtered MAC addresses into the in the on the physical switch. And the satellite. Satellite is a little bit more expensive than all others. Okay, so here's another notes that I want you to write. The factors to consider for making decisions. So please write all of those down. All right, I want you to submit that as also part of the homework. All right, so now let's talk about the PPP over Ethernet. So when you're PC and you're connecting, you can send if you have an ISDN or a dial-up, excuse me, you can use. Oops, sorry about that. You can use the PPP protocol, PPP frame being sent over an Ethernet frame. So PPP is used on all serial links. It's going to make it look like, because remember, PPP is the one that is being used between two directly dedicated wires. So when you have a DSL connections, for example, you will use PPP to send data between one end to the other. So your Ethernet packet has to be stripped out. Take the packet, put it into a PPP and send out. But now you can actually take a packet, an Ethernet packet, and connect, use an Ethernet connection, Ethernet wire, and just wrap it up on a PPP packet. Okay, it uses authentications and Ethernet links. Before we move on, the notes, go back to the notes. Here's what I want you to write down when it comes to PPP over Ethernet. All right, before we get to the example, write this statement down here. PPP over Ethernet creates a PPP tunnel over an Ethernet connection. This is going to allow the PPP frames to be sent across an Ethernet cable to the ISP from the customer router. So you will have an Ethernet cable connected to your ISP, and you are going to send PPP frame on that PPP wire instead of using an old serial connection. I mean, you're going to have an Ethernet connection from your end to the ISP, and so this way you don't have to change wires. You'll send PPP frame in. That's what PPP over Ethernet does. You don't have to really change the wires or change the cables or change the connections. The modem will connect the Ethernet frames to PPP by stripping the Ethernet headers at the end, and then the modem will transmit these PPP frames to the ISP. So we'll be able to do that very easily. All right, so I want you to write these notes. Let's get back. When it comes to configuring them, we'll do that as an example. I'll show you, we'll get to do that in class, how to implement PPOE. So you'll create a virtual interface and you'll get the IP address. Oops, sorry about that. Just to quickly go over this. We'll do this in class again as a class activity. But you'll create an interface, a dialer interface. This is a virtual interface. You'll negotiate the IP address, which means you'll ask the IP address from the ISP. And another thing that you'll get that, and then you transmit the virtual interface eventually. But also you have to remember that you want to reduce the MTU to 1492 from 1500 because of all the headers that you add. The 1500 bytes is the maximum Ethernet frame. So you can't send more than that. So you have to reduce it to 1492 so you can add a little bit more headers because you're creating a virtual interface and and a whole bunch of other headers to the Ethernet. So you reduce the Ethernet frame down a little bit So you'll be able easily to transmit it. All right. Anyways, like I said, how do you do the commands? We'll do that in class. All right. And these are the commands on how to verify the PPP over Ethernet. Pretty much the same as the commands that we've been using whole time. All right. So here is the typical Ethernet frame. So, and it's been reduced to 1492. So you take out the payload, now it goes down to 1452. You add the TCP headers, the IPv4, and here is your PP over Ethernet. So the whole thing looks like now. You add it in here, and then you put the Ethernet frame. So this whole thing is now your packets, really. And it's been surrounded by the PPP, I'm sorry, the Ethernet frame. So it's transfers on the Ethernet wire, but it has a PPPoE header in it, in the packet itself. Uh, let's talk about VPNs. A virtual private network is when you want to connect to two networks that are in different geographic areas. You know, that's called site to site, but you want to use the internet to transmit the data. So what you need to do, because the internet is an unregulated, the public internet is unregulated, nobody's watching it. Somebody might be eavesdropping when you are sending data. So what you want to do is you want to create a tunnel and then pass the data inside that tunnel from one end to the other. Tunneling meaning taking your packet and re-encapsulating it with another packet. Okay, that's really what a virtual private network is. You create a tunnel on one end to the other end and you pass your data through that tunnel. In other words, you encapsulate your packet in another packet, you send it over the internet. Nobody will be able to see what your data is because it's tunneled, re-encapsulated into another packet. The only other person that's going to be able to see it is the guy on the other end. He'll be able to unwrap the tunnel. Now that's unsecured VPN. If you want a secured VPN, which most people really want to do, is you want to encrypt the payload, the data that's inside the tunnel. You want to encrypt it. So VPN is widely used. It's the easiest way, the least expensive way to connect a site to site or even remote users. The benefits of VPN, please write that down. Cost savings, scalability, compatibility with broadband technology, and of course, security. So, and it's really the cost is what brings everybody to VPNs. The only problems with VPNs is that because you're using the internet, you may be prone to denial of service attacks. If you have another thing is if you have a firewall on the other end, the data has to be decrypted before it's passed to the firewalls because the firewalls will not be able to read encrypted data. Okay? So there are site to site, like I said, remote access. You have the dynamic multi-point VPNs is to allow is a Cisco solution for building multiple VPNs pretty quickly. So all you have to do connect and they'll just generate a VPN for you automatically. And the genetic VPN, GRE, the genetic routing encapsulation is the Cisco way of creating VPNs. It's unsecured. The packet that's inside the tunnel is is not encrypted with GRE. So, but it's the easiest way to connect to VPNs to create a VPN between two networks over the internet. So if you're not really worried too much about security, GRE is probably the easiest way to do that. And we'll do that in class as an activity on how to create how to create a VPN using GRE. Okay. And oh, when it comes to GRE connections, I forgot. I wanted you to write these notes, what a GRE is and what their characteristics is. All right. And when it comes to setting it up, we'll do that in class as a class activity, but these are the 5 steps on how to set up a GRE VPN connections between two sites. All right, and verifying. Now let's talk about border gateway protocols. BGP, if we have two different, you have IGP, the interior gateway routing protocol, and the exterior gateway routing protocol. Interior gateway routing protocol, when you have let's say a service provider that uses OSPF or um, or EGRP between routers within an area, and they send updates to each other. Mostly OSPF they use. Those are called interior gateway. OSPF is called an interior gateway routing protocols, and the EIGRP is also called an interior gateway routing protocols because they are within one system, one area. Although with EIGRP we do use an A autonomous system number, but it's really not an autonomous system number. That number, when you type in router EIGRP, let's say 20, and that 20 has to be the same for all the routers. That means it has to be in the same autonomous system number. So it's really an interior gateway routing protocol. The exterior routing protocol is when you want to take this interior gateway routing protocol, such as OSPF or EIGRP, and connect it to another interior gateway routing protocol. We'll use a border gateway, an exterior gateway routing protocol, right? We use BGP, border gateway routing protocol, to connect between an OSPF network and another OSPF network, one autonomous system with another autonomous system. Okay? We're only going to talk about the EIGRP. We're not going to talk about, there's another one called interior boardway BGP, which we're not going to do. All right, so when to use BGP, please write that down. When do you want to use the border gateway protocol? You want to use it when there's a single connection to the internet, just like a stub network. This is also known as a single home. So if you're a company and you have a lot of routers, you have an interior gateway routing protocol, and you connect to the internet, just like this is called, like if you remember, as like a stub network, and you have a default route. So something similar to that. That's when you want to use BGP between them. All right. You do not want to use if you do not have if you don't know how to configure BGP, if you limited understand it, do not use BGP. I'm sorry, I messed up a little bit. You should not use BGP when there's a single connection, when you can create a default route. You should not use it. And you should not use it when you really don't know how to configure it. That's when you should not. So you should not use BGP when you have something similar to a stub network. I think I said you should use it. You should only use it when you have two different networks, one network and another network, another like one that has an autonomous system number, let's say it's 65,001, and another one with another one 65,000, let's say. You connect them through BGP. But if you have a company that wants to connect to the ISP, you don't use it. Okay? Okay, so write this down so you'll know when to use it and when not to use the border gateway protocol. The options, you have a default route only. Oops, sorry about that. So there are three common ways an organization can connect or implement BGP in a multi-homed environment. So if you have a company, such a huge company, and they have multiple autonomous systems, you can use a default only route. This is the simplest method to implement BGP. So it's easy. You can use a default route and an ISP routes if you want, or you can use all internet routes. So probably a lot of people go for default routes, to be honest with you. All right, moving on. In the configuration, we're going to try to do one in class with the class activity. So The 3 steps to implement BGPs will be enable BGP routing. It's just like, it's very simple. You just type in router BGP and an autonomous system number, who's your neighbor, and then you advertise, just like RIP2, believe it or not. And we'll do that as an exercise. And these are the commands that you would use to verify BGP, troubleshoot BGP connections to make sure that you're okay. So we'll do something similar to this. We'll have these 2 routers, and you have a network in here with an autonomous system. It's a very simple connection. Okay, so you have one autonomous system, 65,000, and another autonomous system, 65,001, and you run exterior BGP between them. Just like if you were running, you will notice the difference between the commands. Very simple, but between the commands between RIP2 and an EBGP, I should say. All right, that's it. Hopefully that covers um, chapter 3. So again, we'll take a look at some of the implementation of this with class activities. We'll go over PPPoE, and we'll do some a VPN connection, and we'll do BGP configuration as well for our class activity. All right. Until then, please submit what I told you to submit for homework as a proof that you have viewed this video, and I'll see you in class.